Hello, hey everyone, welcome to yet another check-in session. My name is Mumshad, and I'll be your host for today. I do have a special guest waiting in the backstage. But first, I'd like to get started with some of the routine check-in sessions. We'll check in on the progress. We haven't had a session for a few weeks, mainly because we were at KubeCon Amsterdam, and after that, we've been kind of busy working in the background, getting some of our courses out, and getting some of the features out on the platform. So I have some exciting updates about what's coming up. But today's session, we have a guest who's going to be helping us learn about multi-cloud platform engineering and on different cloud environments. So let me quickly share my screen and let's get started. All right, so what we're going to do is, as usual, we'll celebrate some of the achievers in the community who have completed the certifications and become Kubestronauts and golden Kubestronauts. We also had a recent launch of a campaign, the 100 Days of MLOps, and I'll share a little bit about what we are doing there. We have some updates on the platform, on the app, mobile app, and things like that, which I will share. We'll check in on the course quickly, and then we'll hand it over to Shubham, who is our guest speaker for today. All right, so to begin with, we have Anton's, Kaveen, and Dheeraj, who's completed their CKAs, KCNA, and CKA certifications. So congratulations. Dheeraj is a AKS support engineer at Microsoft. Kaveen is a software engineer at Circles. And Anton's is a DevOps engineer. Then we have Dhruv Patel and Vaibhav Soni, who are DevOps and cloud engineers and SRE at Oracle, respectively, who has also completed the CKA certification. So congratulations. We have Aditya Pancholi, who is now become a Kubestronaut. So he's completed all the 5 certifications that are needed to become a Kubestronaut. So congratulations to Aditya. And we have Nikhil Saxena, who's also completed the Kubestronaut certifications, as well as Lindsay Blackstock, who's also now become a Kubestronaut. So congratulations to everyone. Moving on, we have outside of just Kubernetes, onto the golden Kubestronaut and all of the other certifications. We have Aditya Sharma, who is a technical architect at Luminor, who is also a Kubestronaut, and he's completed the OTel certification. I'm guessing he's on his way to become a golden Kubestronaut. And we have Jan, who is a DevOps engineer, who's also completed his Kubestronaut certification. And again, by the looks of it, I'm guessing is going for gold. So we have the PCA certification that he's recently achieved, as well as the LFCS, which I think is going to come up soon. And then we have Alok Rahul, who is an infra dev specialist at Cognizant, who has completed the Terraform certification. So congratulations to Alok. And we have Yuan Durkesh, who's done the AWS Solutions Architect Associate, and he is an undergraduate. That's some spirit, Yuan. Congratulations. And then we have Dara. Dara has been on a roll for a while, and he's recently completed his Platform Engineering Associate certification. So congratulations to Dara. And then we have Jan, who's also, again, completed the LFCS, so on his way to golden Kubestronaut. Next target is Argo project. So all the best, Jan, on your journey. And then we have Mohana Kandan, who has recently completed the Cloud Native Security Expert. Congratulations to Mohana Kandan. And Dara, again, with the Certified Argo Project Associate certification. All right, moving on to some. So first of all, congratulations to all of those who's completed the certification and are continuing in their learning journey. We recently, we had released last year around the same time, 100 Days of DevOps, which is available on our KodeKloud Engineer platform. It's, for those of you who are not aware, it's one task each day, one hands-on task each day. on DevOps. And then we kind of moved on to 100 Days of Cloud, where we supported AWS and Azure task. And then last month, we released the 100 Days of MLOps. There's a lot of shift that I see happening in the MLOps space. Of course, with AI and everything that's going on, it's expected that MLOps field is going to trend up going forward. So there's a blog post that we had recently written about it that quoted some studies around this. And I think this is probably something that's very interesting. And this is something that we see internally when we look at data, people who are like, what they're learning. There is an uptick in terms of machine learning and MLOps. Now, machine learning itself is a different field, but a lot of things that we have done with DevOps, the foundational topics, the concepts are applicable to MLOps as well. The way you train and how Kubernetes is used to train the models and how you set up the pipelines. There are a lot of learnings to be borrowed from DevOps, and that's basically what MLOps does and all the tooling and everything around it. And we cover all of this in our 100 Days of MLOps program. And we also have a lot of content that is going to come out along these lines in the future. So we're working on a bunch of courses, a bunch of guides and around this. So stay tuned. But if you haven't started the 100 Days of MLOps, go check it out right now. It's free. And if you're doing like one task every day, it's free. If you want to do it all at once, if you have a premium subscription, you do have an option to do multiple at a time. But it's something that you should definitely check it out. Some of the recent courses we launched. So we have the LangGraph course that was launched just last week. So as you all probably know, if you're moving towards the agentic AI and building AI agents for your for internal purposes, LangGraph is one of the frameworks, one of the very popular frameworks, and Ali Reza has put a lot of effort to creating a very hands-on LangGraph course. So it's an engaging course that I think you should try out. We also have a Learn by Doing course that was created by Sai, which is a doing only course, a labs only course where you build AI agents with Cloud Agent SDK. Again, we provide you the keys and everything that are required for you to play around with this and to test and experiment with it. Even if you don't have a Cloud Code subscription, if you're at KodeKloud, you get some free credits for you to for learning purposes. And it's a product called CodeKey that if you go to our platform, if you go to the menu option and look at CodeKey, you'll be able to see how to use keys to work with Cloud Code. And then you have we had the Gateway API with Nginx Fabric Gateway that we recently released, and then also vector databases for GenAI course that was recently launched. Some of the upcoming interesting courses are GitHub Foundation certification by Siddharth, and then we have the data structures and algorithms course from Alan that's going into our foundational track. And then we have another addition to our Kubestronaut tracks. That's the Certified Cloud Native Platform Engineer course that's coming up very soon, and it's put together by none other than Nurhan, who is one of our internal experts. Along with this, I also spent a lot of time last month updating one of my courses. So the Docker for Beginners course is now updated with the latest information. So I've been updating my own courses the past year. So all the Kubernetes courses are updated, and now I'm moving on to the Docker and some of the other basic courses. So if you've ever noticed any of the courses out of date, do let me know, and let me know what area is outdated and what you would like to be included in the newer version of the course. All right, so if you look at the Kubestronaut and the AWS cohort check-ins, if you have not joined the cohorts already, go to cohorts.kodekloud.com, and you'll be able to find the different cohorts that you can join. So we have the Kubestronaut cohort, the one that's started this quarter in April. And there are about 200 people who are on it already. So to join the earlier cohort and that we started in January, we had about 800 people. And we also have the Golden Kubestronaut cohorts that are running. And last and then this year, beginning of this year, we had also started the AWS AI Practitioner cohorts. So this is ongoing as well. So do join and check where you are and how you compare to the others in the leaderboard. We have some fun and exciting activities that are going to come up in these cohorts in the future. So stay tuned. And yeah, so we have one cohort that's fully completed for the AI practitioner. So it's a single course basically. So it's a short cohort of 3 months, and then we have 2 that are currently in progress. There's a sale happening. I think thought it would be good for you to know. Linux Foundation is running a discount sale. So there's a May sale, I think, and oh, this should have ended. There should be another sale that's coming up. Need to check that. We also had made some updates to the KodeKloud mobile app. So one of the features that we shipped the app without one critical feature that you always you all wanted, which is the offline mode. And we wanted to release the basic version out and then add this on. I'm happy to announce that we have now added the offline feature. So now you should be able to download the videos offline and store it offline. And then if you're traveling or if you're on a plane or something, you should be able to watch that on demand. So without having to rely on network connectivity. So if you have not installed the mobile app, please go ahead and try it out. It's available both on App Store and Google Play. Another announcement to make is that we are going to be at KubeCon India in June. That's 2 weeks from now. So if you haven't registered already, please do so. We're going to be at booth 10. You're going to be able to meet us. I'm going to be there personally, and you're going to be able to meet the rest of the team as well. We also have a fun giveaway, which is a very precious giveaway. We'll announce that very soon. But it's got something to do with AI and something to do with machine learning. And if it's something that you're interested in learning, having a device at home, it's a physical thing, so it's not a virtual thing, but it's actually pretty precious. So yeah, points for anyone who wants to guess what that is, but we're going to make some announcements very soon regarding that. But yes, if you happen to be in Mumbai, or if you're are able to make it, please do, and please come and meet us at our booth. All right. So having said that, I want to bring Shubham on board. So Shubham is a platform engineer at Trivago, and he's a friend, and he's come on this in the past 2 months, and he has some new and interesting learnings to share. So I'd like to invite Shubham over. Hey Shubham, welcome to the podcast.
Hey Mumshad, thanks for having me here.
Yeah. Can you tell us a little bit about yourself, what you do at Trivago, what does your day-to-day look like?
Sure. So I joined Trivago in November 23, back when I was working in India still. And most of my career, half of that at least, I was working as a Red Hat instructor and an examiner. So delivering training, and that is something what I was doing in India. But back here now at Trivago, my team is responsible for setting up the data center. We are responsible for setting up GCP, which is where primarily Trivago services live, the ones that user touches in the live request path. And we are responsible for making a managed platform, which is on parity between the two extremes, which is one is cloud and the other one is a data center. More recently, we're working on a managed GPU offering. So we are playing with a couple of H200s that we have in the data center, and just trying to get them ready for the developers to use and experiment for their white coded applications, as we see them coming up almost every day. So that's what my day is at Trivago. Just making sure things are working smoothly on the GCP and data center side.
Yeah, that's very interesting. So the H200s you mentioned, because I've been trying to get my hands on some of them myself. Is it a Are the servers you purchase, or are these like available through GCP?
No, so these are the cards that we purchased. We use Vertex AI in GCP, but again, this gets pretty expensive. And when you have your own hardware, it gives you freedom to also do experiments without really cutting a budget and picking a hole in your pocket. So we got some H200s, and that's what we are now experimenting with. We are working with splicing them with Meg, what
Mhm.
Meg devices we want to have, what different sizes, partitions do we want to use, what people are requesting for. So that all is going on at the moment at the data center side.
Yeah, very, very interesting. Yeah, I'd love to dig into that more at some point. But yeah, I don't want to take away your time now. Let's go ahead with what you have to share for our audience today.
Sure. So let me quickly share my screen. I'm not more of a slides guy, but this time I do have one. So
Okay.
that came as help. Let me share my screen. Um, mm, 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 mm. Okay. Can you confirm if you can see this?
Yep, we can.
All right. So the topic that I wanted to talk about is what I'm very vocal these days, and because this is what I'm doing at Trivago, um, and I would want to talk about the journey, how this started. We were working in the data center before I joined Trivago. Things had already moved from the data center to the cloud, to GCP. So we had all of our staging environments, we had all of our preview environments, we had all of our non-production and including production environments on GCP. And there were talks going around that could we somehow use our data center that we have, because Trivago has data centers here, they had data centers in Hong Kong. Here we rent space from Equinix here in Düsseldorf. And there were always talks about, can we somehow get a managed service using the hardware that we already have? And this is where, when I joined, and this is where my team was responsible to set up an on-prem, which is a managed offering for Kubernetes using Rancher. So we're using our KE2, we are trying to cook up something, and we have two separate environments, which is looking something like this. This is the reason why you want a hybrid platform, but this is also what we had. We had Google Cloud, which was running our production services. We had, customers already using Google Cloud, customers as in the internal teams at Trivago. They're already running on Google Cloud for their QA, for their staging environments. Everything was there. And we were trying to come up with the left side of things, which is the data center. And the reason why we wanted to do this is because we had the hardware, we had the capacity, and we were not paying really anything to invest back when this started. So we thought of, let's give it a try. Let's see if we can really build that. And we did it. And this is how it looked back when these two things were completely separate. We had cloud and then we had data center. But the requirement of talking from the data center to the cloud was growing because you have a lot of chatty applications, as we call them, microservices now. They want to be deployed on-prem because you want to save on cost or there's data sovereignty, but we do want to use applications or services in the cloud. And thankfully for that, we already had network connectivity with Google with a cloud interconnect. Trivago had set this up before I even joined, so that was working for me. But we somehow wanted to access those services with going via that interconnect so that we are our applications can talk to each other, but securely. And this is where the problem started. When we first deployed applications on premise, and they probably want to talk to a GCP bucket to get some data. We had applications which required secrets from the Google Secrets Manager. And this is not related to one cloud, but rather this also reflects on Amazon, Azure, or Google, especially in the part of Google, because Trivago is on Google. We were using service account keys. So if someone doesn't know what a service account key is, uh, think of it as a password that you store in your application. And the client libraries of Google or the CLI, which is G Cloud or GSUtil, whichever you use, it uses those service account keys. It authenticates itself to Google, and then you get your applications talking to each other. It works, It did work. It still works. The problem with these service account keys, however, is that they do not expire, or there's a very long time for them to expire. So if they are exfiltrated, that becomes a very big problem. You have to rotate them every place where you are using it. Second, the problem is much larger on a scale. So if you have a scale of trivago where there are different teams and different teams have multiple applications, and those applications wants to be in the data center, but they want to access GCP, the number of static keys that you have is substantially increasing, and it is very hard for us to keep track of which key is being used by what team. Is it secure? Did they by mistake commit that to a GitHub repository? Is it because it has happened? We are not proud of that, but those are internal. So we caught that. And those were the problems, that managing these service account keys at scale was really big problem for the security and also the platform team. So what they decided is that we do have these cloud and data center environments and they are working, but this fragile link of service account keys is too much to deal with. So our security team and the organization admins and the people who are responsible for this, they decided we're going to go for a policy shift. We are completely disabling generation of service account keys on the organization level in GCP, which is like the highest place where you can disable that. So no one can create it unless explicitly allowed by the organization admins. And this was the time where our managed offering actually crumbled because people would be deploying our applications, and we were very vocal about you can deploy your applications anywhere, they just work fine, which was true. They were working okay because they could access applications on GCP. They did not really care about, or the developers, the teams, they did not need to know that I need to deploy this in GCP or on prem. They were just able to consume the applications, and that's what they care about. Silos are good if they do not need to know the lower level details of it. But as soon as we disable the service account keys, we broke our link between cloud and the on-premise offering. And this was no longer hybrid, but this became two separate mutually exclusive um, environments that we had to manage. And this was one of the really big challenges that we were trying to fill in. We wanted to have that connection. We wanted people to have the freedom, the developers to have a freedom of when they want to deploy and where, be it on cloud, be it on prem, but they should not be able to, they should be, they shouldn't be the one to worry about security. It should be something that the platform team is responsible for. Um, a little of the history. We do have applications and Kubernetes clusters on-prem. We also have applications and Kubernetes clusters on GKE, which is what Google trusts. So you don't have this security problem in the GKE side of things, because when you create a cluster in Google Cloud or any cloud for that matter, it's their control planes. They trust the cluster because Google has created the cluster. It has everything it needs to trust that cluster. We will talk about what it needs to trust it, but they just trust a particular pod because Google knows this pod is running in a cluster. It knows its identity. The problem is when you go from on-prem to GCP, Google does not know this is a pod running in a cluster at Trivago in XYZ cluster in this namespace. It does not know. It does not trust that particular pod. And so it does not allow you to access applications. And this is why we were using service account keys to authenticate ourselves to Google. So Google would trust us. But because we disabled the service account keys, Google could not do that. So this was happening, and we were scratching our heads to why is this happening? We knew why this was happening, but what is the solution for that thing?
Sorry,
Um,
Shubham, if
mhm.
before you go forward, so I just want to make sure our we and me and the audience understand what we are referring to here. So when you say the GKE pods versus on-prem pods, so I'm assuming that you have a cluster that spans across both. Is that
Okay. This is a good question. And the answer is no. We have clusters which are dedicated running in GKE or running on-prem. We don't have a cluster who has some nodes running in
okay?
GKE, some workers are running on-prem. We have completely separate solutions.
Okay. So when you say the on-prem pod, tries to connect to services that are hosted on Google, that's where the identity issue happens, right?
Yes, yes. And to fix that problem is where we were using service account keys. So you can download these keys, you can create them in a Kubernetes secret, you can give them to the pod, and the pod in the application inside that pod refers the service account token. It gives it to Google, and Google says, yes, because I created that token for you,
Yeah.
and I trust that token. That means you are someone who is valid to use that token, and I would let you have the access.
Hmm.
And that's what we disabled because those service account keys could be very well, exfiltrated. They were a problem at scale. They were less auditing because you have so many of them.
Yeah.
It was a challenge for us to use that, and that is why Google was no longer able to trust our on-prem pods because it doesn't know them anymore because there's no service account keys enabled.
Got it. Okay, that's helpful.
Yeah, okay. Um, Now, a little bit of why Google trusts your pod running in GKE. This is important so that we can do the similar thing which is running on-prem. Google trusts the pods which are running in GKE. And what you can do with Google Cloud is when you create a pod in Google, which uses G Cloud CLI or which uses any of the SDKs that Google has to talk to the cloud APIs, you can create a Google service account as well. So there are two service accounts involved. One is the Kubernetes service account, which is used for your pod. This is all GKE stuff, right? On Google, you can also create a Google service account and you can map these things together. So you can have something like, say, if I show you GKE pod annotation, Kubernetes service account, this is something you can do annotate if I can find that. There's some annotations you can give on your service accounts. This is probably the one. If I can find it somewhere. There you go. So this is how in your Kubernetes service accounts, when you're talking about GKE, you can have an annotation of which Google service account do you want to use. So they map with each other. Your pod runs with a service account that says on Google, I want to use a Google service account. So when a pod is created, um, it is given a token, and every pod which is running is given a service account token, which looks something like this. Let's first talk about that because that is the identity of a particular pod. And this happens everywhere, whether you are running it on-prem, whether your cluster is in GKE, whether your cluster is in Azure. This happens everywhere. So when you create a pod, it is created by a service account whose service account token is injected in a pod as a projected volume. And these are some claims which are available in that particular token. It's a JWT token. We will look at that when we do the demo. It has a couple of information about that particular pod's identity. It says who is the audience for this token or who this token is intended for. When was it issued? This particular token is expiring at, who is the issuer, and it tells you the pod name for which that token was created. It tells you the node on which that pod is running. It tells you the subject, which is the service account used to create that particular pod. Mumshad, let me know if I need to repeat that a little bit.
No,
Um,
yeah, no, that's very clear. Yeah, very easy and very clear.
okay, okay. So this is irrespective of GKE or on-prem or Azure, as I said. Every pod that you run in Kubernetes, it is created or it is running using a service account. And Kubernetes by default creates a token for that particular service account and adds it in your pod. And this is the reason why applications which are running in pod, they can talk to the Kube API server because they can use this particular token. This is the foundation of any Kubernetes-based operator that we see now because they can talk to the API server using this token that has already been given to us in the pod by the Kube API server. So how does GKE use that to trust the pod which is in GKE? Now that we know because of this token that this is the namespace, this is the pod name, it is running on certain node, on GKE, there is a component called the node metadata server, or it's just called the metadata server. This runs as a daemon set on every single on every single node. It does a lot of magic in the background, which I'm not going to talk about how it does. It has IP tables, it touches networking, but overall, what it does is when you run any Google client library or gcloud command in your GKE pod, it takes that token, the Kubernetes service account token, it presents that token. So the metadata server takes that Kubernetes token and it presents that token to a service called secure token service. And this is something which is happening in the background. You never care about this. All you care about is my app should be able to access my storage. But this is all happening in the background for you. The service account, the security token service or secure token service is responsible to validate if this token is indeed created by a cluster or the Kube API server that Google trusts. And Google has this trust of the cluster that it is creating using workload identity. We will talk about that in the coming slides. If I want to talk about the flow again, your pod has a your pod has a Kubernetes service account. You get a token for that. Every time you use gcloud inside that pod or the client CLIs, which is again using the same APIs for Google, the metadata server intercepts that request, takes your Kubernetes token, sends it to Google, and says, "This is the token that I have. Do you trust this or not? If you trust that token, can you exchange this token, this Kubernetes service account token, for a federated OAuth 2.0 token?" And that's what the STS service does. The secure token service is a broker. It does two things. It takes your Kubernetes service account token, it sees this token, it sees it is trusted, and it gives you in place of that an OAuth federated token. Now you get this token and you give it back to the application, and using this Google service account annotation that we talked about. So basically your pod is running, you have a service account, it is annotating, there's an annotation which tells which Google service account you want to use. Then you use that Google service account and you access your cloud resources because your token was already verified by Google that this is running in a cluster which I trust. I hope this dance makes some sense because that's the foundation of what we're going to do as a demo. So this was the story. Again, this is how GKE does, and you do not have to worry about this. The only thing you need to care about is when you create a cluster in GKE, you enable the metadata server daemon set on top of that. And all your worries are taken care of. You do not need to care about how would my pod application, my pod in GKE authenticate to Google or access my buckets, access my secrets. You don't have to worry about that. You just need to enable metadata server. You just need to create a Google service account that would be used by the Kubernetes service account, and you basically get your work done. As long as the IAM permissions are, allowing the Google service account to access a resource, you're good there. And this is what the SCS service and the metadata server in the background does it for us. And that's what you need. That's also what your hybrid platform really needs. You want Google to trust your cluster. So in the end, you want Google to trust the tokens that your cluster is generating for your service accounts so that it can allow you to access your Google Cloud services. So I want to stop here, Mumshad. How does it look like?
Yeah, no, this is great. Yeah, I think it's easy. You've explained it, very well. So yeah, I'm with you.
Okay, all right, great. Because there's no one better than you to tell me that we need to go on some other, slide again. Let me know, and I would be happy to do that.
Yeah, no, I think as you show this, maybe as you show the demo, it may be good to just pull that slide back and then just show us where we are. I think that might help. But yeah, so far so good.
Perfect. Absolutely would do that. So this is what the hybrid platform needs. The same treatment that your GKE pods are getting without lifting and moving to the cloud because you already have the hardware, you already have the on-prem offering for Google for people to use, which is internal to the company. You want Google to trust your pods on-prem, just like it trusts the pods running in GKE. Or you want to lie to Google, and this is the slide title, convincing Google your pod is running in GKE without really moving it there. Because you do not need service account keys when you are running in GKE. So why would you need the same thing when you are running on-prem? And that's the whole story. We do not need that because it's a gap in the security. And the answer to that is something called workload identity federation. And this is the beautiful term because it absolutely captures what you are trying to do. You are not giving a secret key, but rather your authentication is being federated by a security token service, and we will see how that happens. So on the Kubernetes cluster on-prem, this is not GKE now, this is completely on-premise. When we install a Kubernetes cluster, and I will show you that, when you install a Kubernetes cluster, your Kube API server for the service accounts, it acts as an OIDC identity provider. So this is the one responsible to generate these Kubernetes service account tokens, which are injected in your pod. If I can probably just show you, let me create a cluster for me, and I would have uh, a cluster, a file called vcluster.yaml because I'm using Wine for all of my workloads. So I will do vcluster create, and let's do that as KodeKloud. And I want to use Docker as a driver. And this is going to give me a kind like cluster, but this is Wine vcluster in Docker. Now, while this is all happening, let's come back to the workload identity federation. When you create a Kubernetes cluster, there is a set of JWK keys which are created for every cluster. This is irrespective of cloud, irrespective of Azure, GCP, whatever. You get some private keys which is used to create these tokens. Uh, I will not say private keys, but these are the JWK keys which is used to sign that particular token. And this is what you get with these keys. So your cluster has the set of JWK keys, and it is used to sign the particular token. And the token looks something like this. If I do k get nodes, I've got my nodes ready. And if I do k run, let's say if I want to run an Ubuntu image because I want to show you how that token looks like, this is a very simple pod which I'm running. It doesn't have a deployment because we don't care about. All I care about is for this to be running, which is now here you can see it's a pod which is running. So if I do exec in Ubuntu and bash, and if you just do df, which shows you the mounts on your files on your mount table, you can see that the token is available at this location. And this is the token which is for the service account that your pod is using. And every pod has a service account, which you can see when you do kget pods. My pod name is Ubuntu, and I grep for service. And you see, the service account that my pod is using is called default. And I'm in the namespace also called default. So I'm in the namespace default in my cluster. My service account name is also default. And that's what Kubernetes has created a particular token for. And this token, if you would take that, and if you would go to jwt.io, let's decode that particular token, you would see the same information that I was showing. It shows a lot of things about that particular pod's identity. It has a lot of claims. So every token, every JWT token has a claim, which is like a fact that shows the fact about that particular token. So remind me later. So who's the audience for that token, or who this token was created for? When would it expire? Because tokens are expiring automatically or renewed by Kube API server. What I want you to see is this Kubernetes.io namespace. So just with this token, you get an identity, or your pod has an identity which tells the namespace it's running in, which tells you the node on which this is running, which tells you the name of the pod that this token is signed for, the service account it's using, and there's also a subject, which is system service account default default. This is the syntax in which we represent our Kubernetes service accounts. So system service account is a group of our Kubernetes service accounts, default being the namespace, and this default being our the service account in the namespace that we are using. That is an identity. The whole thing I want now is if somehow I could get Google to trust these tokens, because I want Google to now understand that this token was signed by a cluster or by a set of JWK keys, which I now trust. And that's what Google does for its own clusters. When Google creates a GKE cluster, it trusts the keys of that cluster. So any token which is signed by those keys is already trusted by Google. That's the same thing we want to have. And for that, we have a service called the Workload Identity Federation. What you do in this case is you give your public JWK keys to Google, and you say, Google, if you get a request of a token which is signed by these keys, you should trust that. You now have the key. I'm asking you to trust it. Trust that as if you would have done the same thing for a pod which is running in GKE, and give it the access based on the IAM, of course, which I would configure later. But that's the relationship. That is the federation you are doing. Think of this as when I come from India to Germany, the people who are sitting at the border control, they do not know me. If I'm the pod, if I'm the workload, and they are Google, let's say, they don't know me, just as Google does not know my pod. They trust my passport because that is given to me by a country that their country trusts. So Germany trusts India or Indian passport, so they can let me through. That's the same thing what you're doing. You are telling, trust this cluster. If it gets you a Kubernetes service account token, trust that token and let it access my Google Cloud services. That's essentially what you're doing. So this is federating your identity, taking your token, giving you an OAuth in exchange, which is a short-lived token. So this completely eradicates the requirement of any service account keys. It gives you a short-lived token, which is usually 1 hour long. This token is expiring automatically. If that expires, your G-Cloud CLI or SDK would use the STA service again to get a new token. So you never have to worry about this token being out of your cluster, because their timeline or their lifetime is very less compared to a service account token. This is what the Workload Identity Federation does. And how do you configure that is there are a couple of components in the workload identity. There is a workload identity pool. There's also a provider, and we will do all of these things demo hands-on. But a pool is like a bucket where you can create your trusted identities. For example, I could have a pool based on geographical location. So I would say I have a workload identity pool, which is for my clusters in Europe. And then I have another pool, which is for my clusters in EMEA. I have a pool for my team called development. And within those pools, you can have multiple providers. And these are the connections to a specific cluster. This is where you can have all the clusters giving their JWKs to Google. You can have entries for every cluster in a particular pool as a provider. And we will do this as a demo. This would make a lot more sense. We talked about the anatomy of a Kubernetes identity. Somehow, we want this identity to be trusted by Google. Essentially, we want the token to be trusted by Google. So we would give our public keys to Google. And this is then what's going to happen. This is how it will look like. When you are running on-prem and you want to talk to GCP, you take your data center Kubernetes token, which is something we saw. It is automatically added to your pod. You take that token and you go to STS, which was the secure token service. You tell STS that, hello, I have this token. I would like to get a federated token against this. STS says, okay, wait, I will check First, if I trust that token, if you have configured me to trust that token, which you would do with the workload identity pool and provider, it checks the attributes and conditions. We will come to that. And if everything is okay, it gives you the federated token. And then you use that federated token, or your applications will use this federated token to access the GCP services, hence the name Workload Identity Federation. And as I said, these tokens are on the fly and they automatically destruct themselves. You don't have to worry about managing them on scale because they're not really a problem compared to what the service account keys were doing. So this is a bit of distinction between both of them. A service account key is something that contains the actual goal for you. It's like it's like the key for you. If that is taken by anyone, they can just open the log themselves. While the credential config file, which is what we use instead of a service account key.json, this credential config file tells you how to get to the key rather than what is the key. So your G-Cloud CLI or your Google Cloud SDK or however you are developing the application in your pod, they do not really see a difference. They just see either you give me the actual secret or you give me the map, and the SDK is smart enough to know the difference between what is given to it and go to STS, go to do the federation, get the federated token, and go to the services. It knows about that. That part is already configured in the SDK. And that's what you now give to your application. You do not say what is the key or what is the token. You tell it how to get the token. And this is something which is completely public. It does not contain any sensitive data. You know, I could give it to you and you wouldn't be able to do anything with that unless I give you access in my Google Cloud. So this is completely public. It could be stored safely in a config map and be presented to the application, and we can be done with it. We'll come to the CEL gatekeeper a little later, and then once you have, once Google trusts your token, that is one thing. Google trusting your token and giving you the OAuth federated token is one thing. The second thing is IAM. It's not like if Google trusts your Kubernetes service account, you will be able to spin up yourself a Vertex AI with H200, right? This would be super expensive. That's not something we want. And here's where your IAM comes into the picture. You could say, Google, I want you to trust the token coming from this particular cluster. However, what can this token access? I would tell you using the standard IAM permissions that you have in Google Cloud, or maybe in Azure, or maybe in Amazon. So imagine you are building yourself an operator that wants to talk to Google Cloud, and it will, spin up an EC2 instance or a compute engine machine. So you did the federation, and now your application goes to, it goes to the compute engine, says, I want to create a VM. You have to have IAM permission for that as well, because Google does not trust anything. It's not like I can just come to the country with my passport and I can start working anywhere. You really have to be allowed by the responsible parties. In this case, the IAM of Google has to allow that this token, even though I trust it, even though I know the cluster, can only do limited set of actions on my Google Cloud environment. And that's the beauty of federation with IAM bindings. So this is what you get in the end. With the legacy service account keys, you have a lifetime of those keys, which is usually 10-year or until you expire them, compared to the workload identity federation that expires automatically in 1 hour. There is no exfiltration risk because the credential config file compared to the JSON of service account keys is entirely public. You can keep it public. I mean, it doesn't contain the sensitive data. It contains the location or how to get the actual token. And here you have the granularity because you can actually see which namespace and the pod is now accessing your secure token service, because your token, the Kubernetes service account token, has all this information. I just showed it in here. When you decode this Kubernetes service account token, you get all of this information. So Google does now know your pod as well it knows the GKE pods because you're giving this information to Google. And you do not have to do any sort of key management because there's zero keys to manage because there's no key really involved. And the enforcement is not just IAM, but also something called common expression language, which I skipped because I wanted to show this in a demo that would make more sense. And that's what we would do, right? So if that's all good now, I would want to go to a demo. If let's do that now. Should we do it?
Yep. Let's go ahead.
Awesome. So as I said, this is a brand new cluster which I created. And as I said, every cluster has got a set of JWK keys that is used to sign the particular token we just saw. So you can do k get, and there's an endpoint using hyphen raw. You can do it is at OpenID v1 JWK. This is the key or the keys Kubernetes is using to act as an OIDC identity provider for your service accounts, not the human accounts, but a service account to generate the token. And there's something that would be interesting to do. And because I wanted people to actually try this at their home, I have this Terraform module that does the same thing for us. So first thing we do is let's go to my console and I would make a new project. I would call that Code Cloud session or cohort. Let's do it this way. And I don't want any organization because this is my private Google account. And this does not, it doesn't require you to spend any money as long as you don't do crazy stuff with your token, which is creating an H200 Vertex AI. Don't do that. It's expensive. So let's go to the project, and if I go to IAM, this is where I will find my workload identity pool and provider. Somewhere around here, it is under the service account keys. So you can see I don't have any service accounts. I only have one IAM myself. I'm the owner of that project. And if I go to my workload identity federation, this is where I will create myself a pool, which is like a bucket for my providers. And there I would grant them access. So let's do that. But I rather want to do this with Terraform. So let me quickly go to what we are going to do. I'm going to create an identity pool. And let me quickly fix the project ID because I changed it now. This is KodeKloud Cohort. And I would go to my project, and the project number is this one, right?
Actually,
And
I
I'm going
got the KodeKloud spelling on the one you put KodeKloud. Yeah.
KodeKloud it is. Okay, let me just then
I can change it here.
do a C here. It is easier for the time. And I'm going to remove the test because this is something when I was testing if the Terraform is still working. That's all okay. All right, so we'll come to what this annotation with this attribute and assertions are. We'll come to that one as well. I just want to do this demo and we will talk about that. So first thing we do is we create a pool and then we create a provider. So I would do this first and then I would show you how it looks like in the UI. So let me go gcloud auth revoke because I don't want to use my trivago account, but rather I want to use my own. So let's log in with that. Give me a second. Okay. I want to do auth login, and this is the account that I want to use. There we go. This should be all fine. And now I'm authenticated. And my project I want to set as something called KodeKloud Cohort. There we go. Okay. Now I would like to create this with Terraform. So I'm going to remove my Terraform state because I want it to be completely new. So let's do a Terraform apply. And here's what's going to happen. So the first thing it creates me is a pool, and then it creates me a provider. And we will talk about what the provider looks like. But before that, I actually want to do something else, which I would show you in a minute. I would need to get my keys and put this in a file called jwk.json. We will see why did we do that. And let's do it. There are a couple of other resources which are created. We'll talk about that later. And let's see if we can create the pool and the provider. It looks like there is an IAM error, which I think I know why, because Terraform is a little bit weird when you use gcloud. I've got this in issues.txt. I need to export my own token so Terraform can now apply that. So now once we do this, if you go back to your workload identity pool and provider, you're going to see something new in here. Let's go to IAM, workload identity pool, and you can see a new pool has been created, which has a provider called hybrid platform, and this is type of OIDC, which is what your Kubernetes API server behaves as an OIDC identity provider for your Kubernetes service accounts. And this is the name again. Now, this is something which is very, very interesting. When you are creating a provider, you are essentially asking Google to trust a particular token. And there are a couple of things you need to do in this. First thing, you need to give your issuer URL. Let me maybe zoom in. The issuer URL is the URL of your Kubernetes cluster that has issued the token. This needs to match the ISS for your token. You see here, the ISS, which is the issuer who created and signed this token. So you need to take the entire string as it is, and you need to add it in the issuer, right? Second thing, I did something which was Kubernetes, which is kget raw, and I put this into a file. The reason why I put my JWK into a file is because my cluster is not publicly reachable. See, if your clusters are publicly reachable, they do have a OIDC endpoint for the JWK. You can just give it here. You can just give that URL, and on the fly, Google will download those JWK. But my cluster is offline. It does not have any, public. It doesn't have any public endpoint. So Google could not connect to my cluster. Hence, I downloaded the keys and gave it to Google, so that it knows this is the JWK file that my cluster is using to sign those service account tokens, the Kubernetes service account tokens. The next thing is the audience. You have to tell Google that the token that you're about to get from this issuer, it should have this issuer. It should have this, it should, use this JWK file to validate if it has this issuer, and also if the token was created for an audience, which is, you can have multiple audience in here. Audience is just like another fact from your token, which is here. It's a list of people or parties this token was intended for, and this token was only supposed to be used by Kubernetes itself. So you could just take that and put it in the audience section. Now, this is, you can think of this as another set of IAM or trust that you're building, that when you get a request, validate the token with this key file, with this JWK. The token should have an issuer which matches the token's own issuer, and the token should have an audience which matches the audience that I'm configuring in the provider. And here's what's called an attribute mapping. And this is extremely important for us to get this right. See, Google does not know the structure of my tokens that I'm sending it, right? It does not know whether I want to work on something which is a node name. Maybe, it could be a requirement that in your cluster, you only want to trust the pods which are running on certain nodes. You want to be very creative with that. It's a requirement that if your token is about to expire in less than 5 minutes, you do not use that request, which is, again, here's the expire at since epoch. So all these different fact that your token has, you need to present it to Google in a way that Google understands it, or Google, it understands that. It does not know. Can you hear me still?
Yeah. We're good.
Okay. So Google does not know what is Kubernetes.io namespace or Kubernetes.io node. It doesn't know about that. You have to do a mapping for Google to your token's facts. So let's say if I wanted to only allow um, certain nodes that my pod, if it's running on worker 2, it should be able to authenticate itself to Google. Worker 1 or anything else should not be able to do it. Before I could do this, I need to tell Google this field means something to you. And that's what you do in the attribute mapping. Think of your entire token as let me see, token and version. There you go. Think of your entire token, which is this particular token, wrapped around another key called assertion. And if I could do assertion and I could do give me the pod name, it returns me the pod name called Nginx. If I was to go and say kubernetes.io dot namespace, it gives me the namespace called default. And that's how you tell Google to extract these facts from your particular token. So you are saying assertion.sub, which happens to be, if I do assertion.sub, you see assertion.subject. This is my service account name. That's the bare minimum Google needs to know the name of your service account that's coming, that the token was signed as a subject for. You can have then your own custom, you can then have your own custom mapping. So if I would say, hey, Google, attribute.namespace, it's going to read the data from my token as assertion.kubernetes.io.namespace, which gives it default. Then I could also say node.name, which is worker 2. I could do the same thing. And I could do attribute.my_node name or a node name on a pod node name. And I could do the same thing in here as not but namespace, but this time it would be node. And then you would have the same thing, name. So this is a way of extracting what the token is saying as a fact for Google to understand in its own language, which is the attribute mapping. That's what the attribute mapping does. This is extremely powerful because you can be very, very creative with this. And this is something done in the attribute conditions. See, just because your token is trusted, it does not automatically mean this token should be allowed to have some sort of access. And Google has multiple layers to stop your token to access something it should not. First one is it should map the issuer, it should map the audience. Then there's the condition. And I could say, you know what? There's an attribute called attribute.namespace. The token should only be federated even before IAMs come to the picture, even before you see if the token can actually do something. I can tell my workload provider, identity provider, that only exchange for a federated token if the request is coming from a namespace called default. And you could be very, very creative with this. I could say something like and I could say attribute dot pod node name in, and I could say worker 1. This is, of course, not a valid CEL. You can always look on the documentation. But what I'm telling you is you can be very creative. You can say, if my pod who's asking for access to Google is in a namespace called default and is running on worker 1 and is asking for the token between 9 to 5 p.m. and the location of the pod is this, you can be very granular with the attribute conditions. It's going to then give you a federated token. If you do not fall in these categories, it will simply say, I'm not going to give you a token. Even though you are in the cluster I trust, I don't trust you in the conditions. And this is what we were talking about in our CEL. You see in here? That was the CEL gatekeeper we were talking about. So you can be very creative. You can say this token, even though you trust it, it has to maintain or pass all the CEL conditions for it to get a federated token. And this is done by common expression language, which is pseudo English. And it makes our lives easier to have security against who can federate or get a federated token. I'm just going to keep it back to default because I know this is an invalid one. And I'm just going to cancel because this was created by Terraform. I just wanted to show you how you could do that, or what does it look like in the provider. Now the provider is done, but your pod still needs to consume this. How would it get access to a secret which is created in my secrets manager? So let's do that quickly. I will go to a secret manager in Google, and let's create a particular secret. I will enable the API, and I will create. Okay, I should have a billing account. Again, this is not going to cost you anything because secrets are, I'm just going to create one secret. It wouldn't cost me anything. It just needs a billing account for that particular project because this is a new project that we created. Let that enable for a second while we go and tell our pod to consume this workload identity pool and provider. So I would go to my project, which was KodeKloud Cohort. Let's go back to our workload identity. Let's go back to our workload identity federation. And the way you could do this is you could actually go to add grant access. So you can say you want to grant access to this pool and all the providers that are there, but how do you want to grant access to your workloads? There are different ways of doing it, two ways. One is the whole flow we talked about. You take a Kubernetes token, you put it to STS, the STS does validation against your provider, it gives you a federated token. You take that federated token directly to IAM and you access your service. The other one is through a service account impersonation, which we are not going to talk about. That has another step, which would be too much. So I'm just going to say I want to download the config, and this is for my hybrid cloud platform provider. And this is where you need to give the path where the token is going to be available for you. This is something you would use inside the Kubernetes pod because your application who needs access to Google Cloud is running in a pod. So if we go to the pod,
sorry, Shubham, sorry to interrupt. So that config is what you mentioned earlier, right? The config that you download, which has no risk associated with it because it's just a config.
Absolutely. That's the one that we talked about. And this is the one we will use. And I will show you the content of that. So we will see it's not really anything which is sensitive. And that's why you could just give it as a config map. And even if this is exfiltrated, no one really can do anything because you have to be in the right conditions. You have to be with the right audience, the issuer, and then IAM. So there are multiple layers of allowing your particular token or your workload to access the resources.
Yeah. And the other option that you showed was the service account impersonation. I know you mentioned, so we don't have to look at that, but at least can you compare the two approaches at a high levels? And is that easier? Is that going to make the whole workflow easier?
So I would rather say a service account impersonation can make it a little bit difficult and easy depending upon what the situation is. So for example, if you have, let's say, 100 namespaces, right, and they should access a particular GCS bucket, rather than having 100 entries in IAM, you could tell that these namespaces are allowed to impersonate a Google service account and give access to this one Google service account for reading the secrets. That is one way of impersonation where it can make your life easier. When you do impersonation, the difference is when you take your Kubernetes token, so the whole flow looks like you take a Kubernetes token, you pass it to secure token service, you get the federated token, you talk to IAM, you go to your resources. This is the recommended federated identity. If you throw in service account impersonation in the middle, you take a Kubernetes token, you go to STS, you get a federated token, you go to IAM to impersonate a service account, you get another token, and then you take this token to IAM for accessing the services, and the flow continues. It's just one more token that you have to exchange because you want to you say that Google has trusted me. It gave me this federated token. Now I want to use this token to impersonate a service account. I would go to IAM, get the impersonated token, then go back to IAM to see if this token is allowed for access of service and access the service in the
Yeah.
future.
Yeah.
So it's just a bit more steps, but there are pros and cons of that. The recommended way of doing is without impersonation because it adds one more step.
Got it. Got it. The reason I ask is when we are building like agentic workflows internally, so with Cloud Code, and we're trying to build skills and build workflows where Cloud Code can access some of the services on our Google Cloud. One of the options we explored was using a service account impersonation. So temporarily you get, so every user has their own kind of user accounts on Google Cloud, and they use service account impersonation to just get access to what they want. And it it opens up a Google Auth login page. You log in, you get a temporary token, and you do service account impersonation with that, and then work, rather than downloading a service account token and storing that locally.
Yeah, I see. Okay. Yeah, there are different ways, as you said. One way is with the impersonation. One because I think, and don't quote me on this because I haven't tried. I heard from a senior engineer at Trivago that federated identities work really well with Kubernetes-based workloads, or when you are using the application default credentials. But in your case, you're calling with a browser, right?
Yeah.
So you get the token from there, and then so that's probably where the federated identity might not work. I will have to check. Um, but yeah, a service account impersonation would definitely work there, as what you're doing already.
Yeah. Okay. Thank you.
Yeah, no worries. So we can download the config, and this is the one that I was talking about. I will show you how it looks like. The only thing it needs from you is which provider do you want to use? So against which provider do you want your token to be checked? And the OIDC token paths. This is the path where your token is stored inside the pod. And our token is text format. It's not JSON. So I'm just going to do text and I would download the config. And if I just open that here, this is what the credential config JSON looks like. You're talking about, you are telling that my credential source is this particular token, which is where the Kubernetes service account token is stored. I want to do the federation at this secure token service. So you give it a token, which is Kubernetes. It validates against this particular provider. You see here, you have your project name, project number, you have the pool, which is hybrid platform. And inside that, the provider you want to use is this particular provider. And you want to do a JWT token exchange because you are giving it a JWT token. You want to get a federated token as an exchange of that. Let me just quickly check if the project number is the same that I am using. What happened? Do I not have a account? I'm trying to enable that. Come on. Or maybe we could just, it doesn't have to be secrets, but we can also do a GCS bucket list. That also does the same thing.
Yep.
Pretty sure GCS would be already enabled. So let me go back. GCS bucket. Is it enabled? Yes, it is. So I cannot create a bucket because it's disabled. What is going on with the billing? Anyway, at least we should not get a permission denied problem. As long as we are able to see that, billing is disabled, that would be a test.
Yep.
So you can see here, this is the config that you would then give to your application, which is running inside the pod. And see, we already have everything that we need. If I go to my IAM, and I go to my workload identity federation, I go to my pool and provider, I have set the right issuer, which matches my token. I have given the right JWK file. I have given the right audience. I told Google how to extract information from my token. And this is the common expression language that I'm using that you only allow if a pod is coming from the default namespace. That is one layer of security. The other one is if you go to IAM, you need to give this particular identity that you have just created or told Google the IAM permission. In this case, what I did was secret manager admin. Again, this is a broad scope. You don't need to do this, but let me just show you. The principal set or the principal or who should get access looks something like this. The way now, once STS takes your token, identifies it, gives you back a federated token, and you take this token to IAM, you have an identity now, but that identity needs an access. And the way you would give access to your identity is either as a principal or as a principal set. In my case, I'm going it on a group because a namespace can have multiple, service accounts, or I can have multiple namespaces. You could also do this on a per pod basis. So you could say principal and IAM projects. And here you can see this is one way of giving access to a single service account itself. You don't give access to a complete namespace, but you can also say within those namespace, if it's in the allowed list, the only service account I trust is called trust me. So with principal, I'm targeting an individual entry. With principal set, I'm targeting a group. In this case, I want to have the IAM trust my attribute.namespace whose name is default. So this is my principal set. And the role that I'm giving for this principal set is secret manager admin. If I wanted the same guy to have access to let's say buckets, I could access it, but I could say, this is my principal. I want this to be having my bucket. So cloud bucket role. So let's say storage bucket viewer. I would just say storage bucket viewer. And this guy would now be able to access my buckets as well, along with the secrets. Now, this IAM thing gives you access via IAM API because you always go via the IAM API after the federation. But how would your pods access that? And the way the pods would access it is when you go inside the pod, you would make a file called cred.json. Let me install a couple of packages in here. Let me do Kubernetes, and here I would do gcloud install. I'll install a couple of things so we can see if things are working for us. This would take a little bit time. Let's do that. Let's do that. Wait. I wanted to do this before I came on the call, but I thought this would actually be better if I do this during live. So that's why you got to install all the packages again. But I hope that's not a problem. Let's see.
Yeah, no, that should be fine.
So let's do cred.json. And this time I want to copy my map, not the key. And I want to do gcloud auth login. Cred file is cred.json. And here you can see if everything goes good, which I'm hoping it does, we should be authenticated to Google. This is where now the STS exchange is happening. And you see, there was a problem refreshing your current OAuth token list because right now, if I look ls, my token is there. But the problem is I have a space in here. So you exactly need to copy the right location in your cred file. Otherwise, it looks in a different location. It doesn't find the token for Kubernetes, and it doesn't get you the right federated token. So if I do cred.json, here you can see the space. I need to remove that. And if I do again, gcloud auth login credential file, and there you see, that's the beauty. I was able to authenticate myself as an individual And also I'm trusting the group where the individual is, which is with the IAM. So that all makes sense. So authenticated with external account credential for principal, and it is authenticated via your pool and the provider, and your namespace, your Google, your Kubernetes service account itself is here, is trusted. So I could do Google Cloud config set project code cloud cohort because that was the project. And yes, I want to update. And if I do G Cloud secrets list, again, it says, do you want to
Yeah.
enable that? This is so weird. But at least you did not get the problem of, I could not let you do that. It lets you access the secrets. And this is with Google or any other API. If you have access to it, but it is not enabled, it asks you if you want to enable that. And you can see this. I hope you can see this because if I create a new project, no auth, let's do that. And if I run the same thing, Ubuntu image, in the no auth namespace, and if I run the same image, we do the same thing in there, even though the JWT key is trusted, even though the service account token is going to be trusted, but because we only allow one single uh, in the common expression language, we only allow one namespace called default. Any token in this namespace will not be trusted automatically. So if I have my pod and you do the same thing with installing gcloud, let's wait a little bit. And this would show that you can't even get a federated token, let alone it asks you if you want to enable the API because you're not in the part of the trusted namespaces, which is configured by the common expression language. And let me go to my client library. I want to get it here. 8.1, set up Vim for me. I would do Vim cred.json, the same thing as we did. Come on, set up. Cred.json. This is my file. Now I'm Mumshad. I'm actually simulating this file has been taken out by someone. Let's imagine this was in a different cluster or another team got hands off my credential config JSON and they tried this in their namespace, right?
Yeah.
And the token is there. Yes, everything is the same because it's the same cluster but a different namespace. But if I do gcloud auth login with cred file as cred.json, let's wait for that. Let's see what we get back. I'm hoping this would probably a denied. There again, we have the same problem. Let's fix this because I need to fix in the cred.json. Okay, let's try to slow this thing here. So this was the problem. And if I do gcloud login again with the same credential file, you see, there was a problem refreshing your token. The reason why the given credential is rejected by the attribute condition because your namespace, because the token says you are in a namespace called no auth, and this token is not in the list of allowed tokens in the common expression language. So even though this was taken out by another team, I put it on GitHub. Nobody can really use this in their namespace unless I go in here and if I do no auth like this, and if I save it, right? And now if I can do that again, let me try. And you see, now you are authenticated. So, and we haven't even touched IAM yet. There are, as I said, there are multiple levels of security with workload identity. You have to be matching the common expression conditions if you have any. So you could be very creative. You could say only the node that I want, and you can have a combination of and or. So either project starts with prod or service account starts with prod, and within this time zone, you can be very, very creative with these things. And now you get the same benefit of that. which is again, if I do my project ID is KodeKloud Cohort, yes. And if I do gcloud secrets list, you're going to be asked the same question. Do you want to retry this API and enable? I'm not going to do this. I need to see what the problem is with the billing account. But I hope this makes sense on how your applications now on-prem is trusted as it would have been in a GKE cluster, right? So there are a couple of other things that I was planning for a demo, but I think we would go beyond the time. There was Kyverno involved on how do you automate these things so this configuration gets injected into the pods. If you have a deployment if you have a deployment which just has this annotation, because the developer doesn't really need to care about all these things, right?
Yeah.
So I would just tell what I was going to do in a demo. We would install Kyverno. We would create a cluster policy which says if on a deployment there is a label called Work Identity Federation Enable, I want you to patch the deployment so that you have a config map and you are mounting that config map at this location, and you are also injecting an environment called Google Application Credentials, because the G Cloud or the Google SDK looks at this environment variable if it's available and then authenticates itself. This could point to a Google service account key, service account key, or the credential config.json. So for a developer, it doesn't really make a difference. They could just use the same code and the same environment variable. And eventually, once this cluster policy is there, when you create a deployment with this, you would automatically have this file injected in environment variable. Exposing this file, you just use your app, and your app accesses the file, which is credential config, goes to STS, gets a token, gets access to the services, and everything would be what we expect, the way we saw that. So this was an end-to-end demo, which I was planning for, but for the duration of time.
Yeah, no, it's I think we're like 30 minutes past, but that's fine. This has been a great session. Maybe we could plan another session which goes into the other details as well. So we'd love to have you again, Shubham. But yeah, thank you so much for your time. This has been great. Very detailed, really good explanation on what we are doing, and the demo also helps us understand, to see that in practice. I mean, I definitely had to see the demo to understand a bunch of things. Like I need to see it happen. Only then I get the full idea. So the demo was very helpful.
Yeah, it also took me some time to get my head around what is this issue we're doing? Why do I have the common expression if I have IAM?
Yeah.
And I was figuring around with that, and I thought this would be a good idea because once you get the hang of it,
Yeah.
only by a demo and doing it.
Yeah.
So I planned a demo for
Yeah.
the call, and I'm glad it makes sense.
Yeah. And how do you see this roll out internally? Like, have you already? Is this a direction you're going internally at Trivago?
We're actually going much further than that. So we have an engineer, a staff engineer in our team, and what he did, and this is also open source now, he replicated the Google's metadata server on-prem. So we don't have to even this. What we do now is we roll out his metadata server implementation at Trivago, and you can have your service accounts same annotation that you gave in GKE. Your service accounts on-prem also have the same annotation. And when you make access to Google, this metadata server daemon set does exactly what Google Cloud implementation does. It intercepts a request, it goes to STS, gets a federated token, and gets access to the services. So you don't even have to do the credential config JSON at all. This is just my implementation of it because I do not want to build what he did. I wanted to do it a bit differently. So yeah, there are different ways, but we already have a metadata server implementation already.
Yeah, makes sense. Awesome. All right, I think we can wind up now. But once again, Shubham, this was really, really helpful. Thank you so much for your time. Thank you for being here, and looking forward to having you again.
My pleasure was mine, Mumshad. Thanks for having me.
All right, awesome. Well, thank you, everybody, and everyone who's still here. Thank you so much. and for your support. And yeah, we'll see you again very soon.
All right.